Now, in this lecture, we'll answer on two questions. In the first question, we will find out the area of this square ABCD. In the second question, we'll find out the size of this angle theta, that is inside triangle ODE. So we start with the first question. In the drawing, we have square ABCD. Line segment AB equals to 5 units. Line segment PB equals to 2 units. Line segment PD equals to 6 units. And our mission is to find out the area of this square ABCD. So first of all, we will do a construction. We will extend side CD of the square by a straight line. And from point P, we will draw perpendicular on the extended DC. So this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P and the extended CD as point N. In the next step, we'll do another construction. From point B, we'll do perpendicular on PN. Again, from point B, we go perpendicular on PN. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We will define the touching point of the perpendicular from point B and PN as M. Okay. In the next step, we will define side BM as A. Here, the length of side BM is equal to A units according to our definition, and we will define side PM as B. The length of side PM equals to B units according to our definition. In the next step, we will implement the Pythagoras theorem. On the right triangle PBM. Okay. Here, by PT is aberration for Pythagoras theorem. According to the Pythagoras theorem, in the right triangle PBM, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is PB, therefore PB squared must be equal to PM squared plus MB squared. Repeat again. the right triangle PBM. According to the Pythagoras theorem, PB square equals to PM square plus MP square. PB equals to 3 units according to what is given as the equation, therefore PB squared is 3 squared, that is 9, and it is equal to PM squared. PM equals to B according to our definition, therefore PM squared is B squared plus BM squared. BM is A, so therefore BM squared is A squared. So in conclusion, found out that according to equation number 1, A squared plus B squared equals to 9. Okay. So we know that all the angles inside the square are right angles, so all the angles inside square ABCD are right angles. So this angle is equal to 90 degrees. This angle is also equal to 90 degrees. This angle equals to 90 degrees, and finally this angle is also equal to 90 degrees. CD is one side of square ABCD, therefore it is absolutely a straight line. And then when you extended the straight line CD or a straight line, the result must be the result that is CN must be also a straight line. Therefore CN is a straight line. Write it down that CN is a straight line, because when you extend a straight line by straight line, the result must be a straight line. So CN is a straight line. So if you focus on the upper side of the straight line CD at point D, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have in the upper side of CN at point D, we have this angle that is equal to 90 degrees, so the missing angle must be also equal to 90 degrees. In order to complete the sum of the angles on the upper side of CN at point D to 180 degrees, this angle must be also equal to 90 degrees. Okay, so actually we found out that inside quadrilateral BMDN, this quadrilateral, we have 1, 2, 3 right angles. Okay, and the sum of 3 right angles is 270 degrees. Therefore, the fourth angle must be also equal to 90 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, because 270 degrees plus 90 degrees is 360 degrees, that is the sum of the angles in any quadrilateral. Okay. So we focus on the lower side of segment line AM, and the lower side of segment line AM at point B, we have this angle that is equal to 90 degrees plus this angle that is also equal to 90 degrees. So 90 degrees plus 90 degrees is 180 degrees. So therefore angle ABM equals to 180 degrees. So we can write down that angle ABM is equal to 180 degrees. Angle ABM equals to 180 degrees, and we know that any angle that is equal to 180 degrees is defined as a straight line. Therefore, we can write down that angle ABM is a straight line. Okay, angle ABM is a straight line. And if angle ABM is a straight line, it means that line segment ABM is also a straight line. Line segment ABM is a straight line, and if line segment ABM is a straight line, it means that AM itself, that line segment AM is also a straight line. So we can write down that AM is a straight line. AM is a straight line. So we actually know that AM is a straight line. AP, it is given us that it is a straight line, it is equal to 5 units. And MP is part of perpendicular PN, therefore it is absolutely a straight line. Therefore, you can conclude from it that shape APM, this shape APM is a right triangle. I write it down, shape APM is a right triangle. Repeat again, shape APM is a right triangle. Therefore, we can implement the Pythagoras theorem on the right triangle, triangle APM. So in the right triangle, triangle APM, by PT is the version for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay. The hypotenuse in the right triangle APM is AP, therefore the square of the hypotenuse is AP squared. And it must be equal to the sum of the squares of the perpendiculars, that is, it must be equal to PM squared plus MA squared. Repeat again, in the right triangle, triangle APM, according to the Pythagoras theorem, we get that AP squared equals to PM squared plus AM squared. AP equals to 5 units according to what is given us the question, therefore AP squared is 5 squared, that is 25, and it is equal to PM squared, PM equals to B, therefore PM squared is B squared, plus AM squared. What is the value of AM? We define the side length of square ABCD as X, therefore all of its sides are equal to x units in their lengths. So here the side length, here AM, it is very easy to see from the drawing that AM equals to x plus a. AM equals to x plus a, therefore AM squared will be equal to x plus a squared. So actually found out that according to equation number 2, 25 equals to b squared plus x plus a squared. Here we'll open the brackets on this side to equation number 2 and we get that according to equation number 2, $25 equals to b squared plus x plus a squared equals to x squared plus a squared plus 2 times x times a. So in equation number 2 we have a squared plus b squared. But we have already found out that a squared plus b squared according to equation number 1 equals to 9. Therefore we can substitute a squared plus b squared in this equation, equation number 2 by 9. We do it now and we get that 25 equals to a squared plus b squared is 9 plus x squared plus 2ax. So here we subtract 9 from this equation, equation number 2, and we get that according to equation number 2, 25 minus 9 is 16, and it is equal to x squared plus 2ax. Here we subtract x squared from this equation, equation number 2, and we get that according to equation number 2, 16 minus x squared equals to 2ax. Here we divide this equation, equation number 2 by 2x, and finally we will get that according to equation number 2, a equals to 16 minus x squared over 2x. So we actually found out the value of a in terms of x. Okay. We have already found out that quadrilateral BMDN has 4 right angles, and therefore quadrilateral BMDN is a rectangle. So I write it down. Quadrilateral BMDN is a rectangle because it has 4 right angles. And we also know that the opposite sides of a rectangle are equal to each other. That is to say BM equals to DN. BM equals to DN, But according to our definition, Bm equals to A. We can write here Bm equals to A. And for this equation, A equals to Bm equals to Dn, we will derive that Dn is also equals to A. Okay, here Dn is equal to A, so we can write here that Dn equals to A. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we get that in rectangle BMDN, BD equals to MN. BD equals to MN. But according to our definition, BD equals to X. So we can write that BD equals to X. And for this equation, X equals to BD equals to MN, we will derive that MN is also equals to X. MN is equals to X. So we can write there that Mn equals to X. In the next step, we will implement the Pythagoras theorem on the right big triangle, triangle PDN. In the right big triangle, triangle PDN, by PT is a relation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendicular. That is to say, PD square must be equal to Pn square plus Dn square. I'll repeat again, in the right big triangle, triangle PDN, according to the Pythagoras theorem, PD square equals to Pn square plus Dn square. According to what is given as the equation, PD equals to 6, therefore PD square is 6 squared, that is 36, and it is equal to Pn square. What is the value of Pn? It is very easy to see from the drawing that Pn equals to B plus X. Pn equals to B plus X. Therefore Pn square equals to B plus X square plus Dn. The value of Dn is 8, therefore Dn square is A square. So, in conclusion, we found out that according to equation number 3, 36 equals to B plus X square plus A square. Here we will open the brackets on this side of equation number 3 and we get that according to equation number 3, 36 equals to B plus X square equals to B square plus X square plus 2 times B times X plus A square. So in this equation, equation number 3, we have A square plus B square. And we have already found out that A square plus B square according to equation number 1 equals to 9. Therefore we can substitute A square plus B square this equation number 3 by 9. We'll do it now, we'll get that according to equation number 3, 36 equals to 9 plus x squared plus 2bx. Here we subtract 9 for this equation number 3, and we get that according to equation number 3, 36 minus 9 is 25, and it is equal to x squared plus 2bx. Here we subtract x squared from this equation number 3, and we get that according to equation number 3, 25 plus x squared equals to 2bx. Here we divide this equation number 3 by 2x, and we get that according to equation number 3, b equals to 25 minus x squared over 2x. We actually found out the values of a and b in terms of x. Okay, b equals to 25 minus x squared over 2x, and we actually know that according to equation number 1, a squared plus b squared equals to 9. Now we can substitute a and b in this equation number 1 by the values that we found for them. We found out that a equals to 16 minus x squared over 2x. So we will square this expression in order to get the value of a squared plus b squared. We found out that b equals to 25 minus x squared over 2x, so we square this expression in order to get the value of b squared, and according to equation number 1, a squared plus b squared equals to 9. Now we'll open the brackets of those two expressions in equation number 1, and we get that according to equation number 1, 16 minus x squared equals to 16 squared, that is 256, minus x squared is x to the power of 4, minus 2 times 16 is minus 32. So here this expression equals to minus 32 x squared in total, all divided by 2x squared, that is 4x squared, because of the fact that the second expression, this expression, also have a denominator that is equal to 4x squared. We will add the numerator of this expression with the numerator of this expression, and we will get that here 25 minus here we have 25 minus x squared. Yeah, I made a mistake. Question number 1. Actually, question number 3. We have actually implemented the Pythagoras theorem in this triangle PDN. According to the Pythagoras theorem, PD squared equals to Pn squared plus Dn squared. PD is 6, therefore PD squared is 36, and it is equal to Pn squared, that is B plus x squared plus a squared. Then we open the brackets here and we got that 36 equals to b squared plus x squared plus 2bx plus a squared. Here we have a squared plus b squared, that is equals to 9. But here, actually, 36 minus 9 is 27. 36 minus 9 is 27 and not 25. Okay. So here, instead of 25, it is 27. Okay. 27. So here, instead of 25, it is 27. Okay, so we have here 27 minus x squared is equal to 27 minus x squared squared is equal to 27 squared, that is 729, plus x squared squared is x to the power of 4, minus 2 times 27 is minus 54 times x squared. And it is equal to 9. Okay. X to the power of 4 plus x to the power of 4 is 2 times x to the power of 4. We have here minus 32x squared minus 54x squared is minus 86x squared. And finally, 256 plus 729, it is equal to 985. And here we'll multiply this equation by 4x squared, and we get that 9 times 4x squared equals to 36x squared. So here we subtract 36x squared from this equation number 1, and we get that according to equation number 1, two times x to the power of 4 minus 86x squared minus 36x squared is equal to minus 122x squared plus 985 is equal to 0. So here we define x squared as z. If x squared equals to z, it means that x to the power of 4 will be equal to z squared. So this expression in total will be equal to 2z squared minus 122 and x squared equals to z, so substitute x squared by z plus 985 equals to 0. So we have here a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we find out the value of x according to the following formula, that x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, the coefficient a equals to 2, the coefficient b equals to minus 122, and the coefficient c equals to 985. So I write it down. I'll repeat again. In our specific quadratic equation, the coefficient a equals to 2, the coefficient b equals to minus 122, and finally the coefficient c equals to 985. And the variable that we are looking for is z, so we put the data inside the formula for x, and we will find out the value of z, because here the variable that we are looking for is z. So z equals to minus b, b equals to minus 122, therefore minus b will be equal to minus 122, that is plus 122 plus minus square root of b squared. B is minus 122, therefore b squared is minus 122 squared, that is actually equals to 14,884 minus 4 times a is minus 8, and times c is 985, so minus 8 times 985 equals to 7,880. All divided by 2a. A is 2, so 2 times a is 2 times 2, that is 4. So here we found out that z equals to 122 plus minus 14,884 minus 7, actually here 122 square It is 14,884, and 8 times 900, 8 times 985 is 7,880. So here 14,884 minus 7,880 is 7,004. So inside the root we left only with 7,004. Divided by 4. So Z equals to 122 plus minus the square root of 7,004 is equal to 83.6899, all divided by 4. So here we have two solutions that are possible for Z. The first solution for Z is that Z equals to 122 plus 83.6899 over 4. And 122 plus 83.68944 is equal to 205.6899, and if we divide it by 4 we get that Z equals to 205.6899 over 4 equals to 51.4224. Okay, according to our definition, Z equals to x squared, and it is equal to 51.4224. We take a root from this number in order to find the value of x, because this is actually x squared. So x will be equal to the square root of 51.4224, and found out that x equals to 7.17 units. And it is impossible that x equals to 7.17 units. Why? Because if we focus on the right triangle, APM, in this right triangle, APM, the hypotenuse AP equals to 5 units. And we know that the hypotenuse is the biggest side in any right triangle, and especially in triangle APM. In this triangle APM, the hypotenuse AP equals to 5, therefore it must be greater than AM. So if AP is greater than AM, let alone that AP will be greater than AB. So we write down that here AP that is equal to 5 units, and it is the hypotenuse of the right triangle APM. It is greater than AB that is equal to x. but according to our solution, x equals to 7.17 units. And here we have a contradiction. According to this inequality, we get that 7.17 units, it is less than 5. That is a contradiction, and due to the contradiction, we will cancel this solution. That is to say, x cannot be equal to 7.17 units. And we left with only the second solution for z. The second solution for z is that z equals to 122 minus 83.6899 over 4. So 122 minus 122 minus 83.6899 is equal to 38.3101 over 4. So if we divide it by 4, we get that z equals to 9.5775. But what is z? According to our definition, z equals to x squared. But x squared is exactly the area of square ABCD, the area that we are looking for. So we can write down that the area that we are looking for, that is the area of square ABCD, it is equal to x squared, that is equal to z, that is equal to 9.5775 square units. And if we take a root from 9.5775 that is equal to x squared, we get that the value of x is the square root of this number 9.5775, and it is equal to 3.09 units. And here we found out that AB is less, that is equal to 3.09 is less than AP, that is equal to 5 units. So actually we verified that the answer is indeed true, because here this is part of the perpendicular AM, that is must be less than the hypotenuse 5, and indeed x that is equal to 3.09 is less than 5 units. That is the length of the hypotenuse. AP in triangle APM. The right triangle, triangle APM. Therefore, in conclusion, we found out that the answer to this question is that the area of square ABCD equals to 9.5775 square units. We finished with the first question. In the next step, I will present to you the second question. So in the drawing we have a right triangle, triangle ABC. Angle ABC equals to 90 degrees. We also know that line segment AD equals to line segment EC, and line segment DE is twice as long as AD, and DE is also twice as long as EC. And our mission is to find out the size of this angle, angle theta, that is actually in triangle DOE. Okay, first of all, we will define line segment DE as 2A. So here DE equals to 2A according to our definition. According to what is given us the question, we know that AD equals to EC, and it is equal to DE over 2. But according to our definition, DE equals to 2A, so we substitute DE by 2A. So it is 2A over 2. We have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. We left only with A. So in conclusion, we found out that AD equals to EC, that is equal to A. Okay, it is equal to A. That is to say, AD equals to A, and EC is also equal to A. In the next step, I will present to you rule number 4. According to rule number 4, the perpendicular from the center of a circle to a chord bisect the chord. Here, point O is the center of the circle. From point O, that is the center of the circle, we have perpendicular OM. And according to this rule number 4, the perpendicular OM bisects chord CD. That is to say, CM equals to MD. And from the fact that it bisects chord CD, it means that it divides it into two halves. That is to say, CM equals to CD over 2, and MD is also equals to CD over 2. We can implement rule number 4 in our drawing. Here, from the center of the circle, that is actually point O, we will go perpendicular on chord DE. So here, this angle equals to 90 degrees, and this angle also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and chord DE as T. So according to rule number 4, the perpendicular OT to chord DE bisects chord DE. That is to say, DT equals to TE, DT equals to TE according to rule number 4. According to rule number 4. And we know that each part equals to DE over 2. That is to say, DT equals to DE over 2, and TE is also equals to DE over 2, because the perpendicular OT bisects chord DE. That is to say, it divides it into two halves. Each half equals to DE over 2. But here, DE equals to 2A according to our definition, so we can substitute DE by 2A. So we have 2A over 2, we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled, and we left only with A. So in conclusion, we found out that dt equals to TE, and it is equal to A. That is to say, dt equals to A, and TE is also equal to A. Okay. In the next step, we'll define the point of tendency of tangent AB with this circle SM. We'll define the point of tendency of tangent BC with this circle SN. We'll join points O and M together by a straight line. Point O is the center of the circle, point M is the point of the circle itself, therefore OM is the radius of the circle that we define as R. And we have the radius OM that is drawn to the point of tendency. Therefore, according to rule number 1, that the tangent to a circle is perpendicular to the radius drawn to its point of tendency, we get that this angle equals to 90 degrees, and this angle also equal to 90 degrees. We join points O and N together by a straight line. Here, point O is the center of the circle, point N is the point of the circle itself, therefore ON is the radius of the circle that is equal to R. And again, here we have the radius ON that is drawn to the point of tendency, therefore this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1. Okay, so inside quadrilateral OMBN, we have 1, 2, 3 at angles. Therefore, the fourth angle must be also equal to 90 degrees. Quadrilateral OMBN that has 4 at angles is a rectangle. I write it down. Quadrilateral MOBN is a rectangle. Why? Because it has 4 right angles. And we know that the opposite sides of a rectangle are equal to each other. That is to say, MO equals to BN. MO equals to BN. But we have already found out that MO equals to R. And from this equation, R equals to MO equals to BN, we will derive that BN is also equals to R. Here, BN is equal to R. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we get that in rectangle MOBN, ON equals to MB. But we have already found out that ON equals to R, so we can write here that ON equals to R. And from this equation, R equals to ON equals to MB, we will derive that MB is also equals to R. MB is equal to R. So we can write here that MB equals to R. So we actually found out that quadrilateral B N is not a rectangle but a square. Why? Because all of its sides are equal to R. Okay. In the next step, I will present to you a new rule, rule number 10, and we will implement rule number 10 in our drawing. According to rule number 10, if we have this circle and we have the extra point P, from point P we have tangent PA that is tangent to this circle at point A, and we have the straight line from point P that intersects with the circle at point B and at point C. Then if this is the data that has been given to us, then the following formula is true, that AP square equals to PB times PC. Again, AP square equals to PB times PC. AP square equals to PB times PC. Okay, we can implement rule number 10 in our drawing. Why? Because here we will focus on point C, from the external point C, we have tangent CN to the circle, and we have the straight line that intersects with the circle at point E and at point D. Therefore, we can implement rule number 10 in this drawing. According to rule number 10, we get that Cn square equals to Ce times Cd. Again, Cn square equals to Ce times Cd. Cn square equals to Ce times Cd. Repeat again. Implemented rule number 10. The example point C. According to rule number 10, Cn square equals to Ce times Cd. Okay, so Cn square equals to Ce. Ce equals to A, so we substitute Ce by A times Cd. What is the value of Cd? It is very easy to see from a drawing that Cd equals to A plus A plus 8, it is 3A. So we substitute Cd by 3A. So in conclusion, we found out that according to rule number 10, Cn square equals to A times 3A. A times 3A is 3A square. So I write it down. I found out that Cn square equals to 3A square. Here we take a root out of this equation and we get that Cn equals to the square root of 3A square. The square root of A square is A, and the square root of 3 is square root of 3. So Therefore the square root of 3a squared is square root of 3 times a. So I found out that Cn equals to square root of 3 times a, so I write it down. Cn or Nc equals to the square root of 3 times a. Likewise, we will implement rule number 10 and the external point, point A. So I write it down. We will implement rule number 10 and the external point, point A. Why you can implement rule number 10 the external point, point A, because of the fact that from the external point, point A, we have tangent AM to the circle, and we have the straight line AC that intersects with the circle at point D and then point E. Therefore, according to rule number 10, we get that AM squared equals to AD times AE. Again, AM squared equals to AD times AE. So I write it down. I found out that AM squared equals to AD times AE. I'll repeat again. We implemented rule number 10 in the external point, point A. According to rule number 10, AM squared equals to AD times AE. So AM squared equals to AD. What is the value of AD? AD equals to A, therefore we substitute AD by A times AE. What is the value of AE? It is very easy to see from the drawing that AE equals to A plus A plus A, that is 3A. Okay? So in conclusion, I found out that AM squared equals to A times 3A. That is to say, AM squared equals to A times 3A is 3A squared. So we found out that AM squared equals to 3A squared. Here we take a root out of this equation and we get that AM equals to the square root of 3 times A. AM equals to the square root of 3 times A. AM equals to the square root of 3 times A. In the next step, I will copy the right triangle, triangle ABC in a new page, and we will analyze triangle ABC. What is the length of the hypotenuse AC? It's very easy to see from the drawing. That AC equals to A plus A plus A plus A, that is 4A. What is the length of side AB? The length of side AB equals to square root of 3 times A plus R. Again, AB equals to square root of 3 times A plus R. Likewise, the length of side BC of the right triangle, triangle ABC will be equal to square root of 3 times A plus R. Actually, this is the right triangle ABC that I copied from the original drawing. Side AB and side BC, they are equal to each other in length. Why? Because both of them is equal to square root of 3 times A plus R. And those two sides are equal to each other. And we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles are located in front of equal sides, therefore they are equal to each other. So if we define this angle as theta, then this angle must be also equal to theta. Why? Because they are equal to each other. Okay? And because of the fact that this is a right triangle, this angle equals to 90 degrees, so the other two angles must be also equal to 90 degrees in order to complete the sum of the angles in this right triangle, triangle ABC to 180 degrees. Those two angles must be also equal to 90 degrees in total. That is to say, theta plus theta must be equal to 90 degrees. Theta plus theta equals to 90 degrees. Theta plus theta is 2 theta, that is equal to 90 degrees. Here we divide this equation by 2, and we get that theta equals to 90 degrees over 2 is 45 degrees. So I found out that angle theta equals to 45 degrees. Okay, angle theta equals to 45 degrees. So in the right triangle ABC, it is very easy to see that cosine 45 degrees, if we relate to this angle, cosine 45 degrees is equal to BC over AC. Again, cosine 45 degrees equals to BC over AC. BC equals to square root of 3 times A plus R over AC. AC equals to 4A. Okay. So here, cosine 45 degrees equals to 1 over square root of 2. So we substitute cosine 45 degrees by 1 over square root of 2, and it is equal to square root of 3 times A plus R over 4A. Here we will multiply this equation by 4A, and we will get that form A over square root of 2 4A over square root of 2 equals to square root of 3 times A plus R. Here we'll substitute 4 by 2 times 2, and we get that 2 times 2 times A over square root of 2 equals to square root of 3 times A plus R. Here we substitute 1, 2 by square root of 2 times square root of 2, and we get that 2 times and 2 equals to square root of 2 times square root of 2 times a over square root of 2. That is equal to square root of 3 times a plus r. Here we have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 will get cancelled. And we left only with 2 times square root of 2 times a, that is equal to square root of 3 times a plus r. Here we subtract square root of 3 times a from this equation, and we will get that r equals to 2 times square root of 2 times a minus square root of 3 times a. Here we take a as a common factor out of those two expressions, and we get that r equals to a. So what is left from 2 times square root of 2 times a after we took from it a as a common factor? What is left is actually 2 times square root of 2, and what is left from minus square root of 3 times a after we took from it a as a common factor, what is left is actually minus square root of 3. So in conclusion, we found out that the radius of the circle equals to a times 2 times square root of 2 minus square root of 3. Okay. In the next step, I will copy the right triangle DOT in a new page, and we analyze triangle DOT. The right green triangle DOT. Point O is the center of the circle. Point T is the point of the circle itself. Point O is the center of the circle. This point D is the point of the circle itself. Therefore, OD is the radius of the circle that is equal to R. So here OD equals to R. We already found out that DT equals to A. This angle equals to 90 degrees according to our construction. So actually, this is the right triangle DTO that I copied from the original drawing. In the right triangle DTO, it is very easy to see that cosine theta equals to dt over do. Again, cosine theta equals to dt over do. So I'll write it down. In the right triangle DTO, get that cosine theta equals to dt over do. dt equals to a, so we substitute dt by a, and do equals to r, therefore we substitute do by r. Okay. So cosine theta equals to a over r. So I write it here that cosine theta equals to a over r. but we have already found out that r equals to a times 2 times square root of 2 minus square root of 3. Okay, so we'll substitute r by a times a times 2 times square root of 2 minus square root of 3. Okay, it is equal to a over r, and r equals to a times 2 times square root of 2 minus square root of 3. So here we have a in the denominator and a in the denominator, so a will get cancelled. So in conclusion, we found out that cosine theta equals to one over 2 times square root of 2 minus square root of 3. Now we are interested in theta itself, the size of angle theta. In order to get the size of angle theta, we will operate the opposite function of cosine, that is cosine minus 1 on the result, this expression, and in this way we get the value of theta itself. So the opposite function of cosine is cosine minus 1. We'll operate it on the result, that is 1 over 2 times square root of 2 minus square root of 3. In this way we get the value of theta itself. Okay, and this expression cosine minus 1 of 1 over 2 times square root of 2 minus square root of 3, it is equal to 24.203 degrees, and it is equal to theta. So we found out that theta equals to 24.203 degrees. Repeat again, we found out that this angle theta, it is equal to 24.203 degrees. Okay, a little bit greater than 24 degrees. Okay, so we finished with the second question. In the next step, I will summarize the lecture. We start with the first question. In the drawing, we have square ABCD, line segment AP equals to 5 units, line segment PB equals to 3 units, line segment PD equals to 6 units, and our mission is to find out the area of this square ABCD. So first of all, we did the construction. We extended side CD by straight line, and from point P we drew perpendicular on the extended CD. So this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P and the extended CD as N. Then from point P we draw perpendicular on PN. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. We defined the touching point of the perpendicular from point B and PN as M. Then we define side PM as B, we define side BM as A, and we implemented the Pythagoras theorem on the right triangle, triangle PBM. On the right triangle, triangle PBM, according to the Pythagoras theorem, PB square equals to PM square plus BM square. Repeat again, in the right triangle, triangle PBM, PB square equals to PM square plus MB square. PB equals to 3, therefore PB square is 3 squared, that is 9, and it is equal to PM square. PM is B, so PM square is B square plus BM square. BM is A, so BM square is A. So in conclusion, I found out that according to equation number 1, A square plus B square equals to 9. Okay. Then we know that all the angles inside the square are right angles. That is to say, those 4 angles they are both right angles inside square ABCD. So here CD is one side of the square, therefore it is absolutely a straight line. When we extended the straight line CD by straight line, the result is CN. Therefore the result also must be CN, that is the result of extending the straight line, must be also a straight line, because when you extend a straight line by a straight line, the result must be also a straight line. Therefore CN is a straight line. So if we focus on the upper side of the straight line CN at point D, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have on the upper side of CN at point D? We have this angle that is equal to 90 degrees, therefore the missing angle must be also equal to 90 degrees. In order to complete the sum of the angles on the upper side of CN at point D to 180 degrees, this angle must be also equal to 90 degrees. This angle equals to 90 degrees according to our construction, and this angle equals to 90 degrees according to our construction. So in quadrangle BMDN, we have 1, 2, 3 right angles. That the sum of 3 right angles is 270 degrees, therefore the fourth angle must be also equal to 90 degrees. In order to complete the sum of the angles in this quadrangle to 360 degrees, this angle must be also equal to 90 degrees. So quadrangle BMDN has 4 right angles, therefore quadrangle BMDN is a rectangle. So we focus on the lower side of segment line AM at point B. In the lower side, we have this angle that is equal to 90 degrees. This angle it is also equal to 90 degrees. That is to say, the sum of those 2 angles is 90 degrees plus 90 degrees is 180 degrees. So angle ABM is a right angle. Angle ABM is equal to 180 degrees. Okay, angle ABM equals to 180 degrees. Here angle ABM equals to 180 degrees. Therefore angle ABM is a straight line. Any angle that is equal to 180 degrees, it is a straight line. So if angle ABM is a straight line, then line segment ABM is a straight line. And if line segment ABM is a straight line, it means that AM is also a straight line. AM is a straight line. AP is also a straight line according to what is given as the equation. That PM is part of perpendicular PN, therefore it is absolutely a straight line. Therefore, shape APM is a right triangle. So this angle equals to 90 degrees. Shape APM is a right triangle. Therefore, we can implement the Pythagoras theorem on the right triangle, triangle APM. According to the Pythagoras theorem, AP square equals to AM square plus PM square. Repeat again, AP square equals to PM square plus AM square. AP equals to 5, therefore AP square is 5 square, that is 25. And is equal to PM square, PM is B, therefore PM square is B square. And AM equals to B plus X, therefore AM square is B plus X square. Pn is B plus X square. triangle, in the right triangle, triangle APM. So actually implemented the Pythagoras theorem in the right triangle, triangle APM. This is the right triangle, triangle APM. Again, this is the right triangle, triangle APM. AP equals to 5, therefore AP squared is 5 squared, that is 25. PM equals to B, therefore PM squared is B squared. And AM equals to X plus A, therefore AM squared is X plus A squared. So, in conclusion, we found out that 25 equals to B squared plus A plus X squared. We open the brackets on this side of the equation and found out that 25 equals to B squared. We open the brackets, X plus A squared equals to X squared plus A squared plus 2XA. Here we have A squared plus B squared, and according to equation number 1, A squared plus B squared equals to 9. Therefore, we substituted A squared plus B squared in equation number 2 by 9 and found out that 25 equals to 9 plus X squared plus 2AX. We subtracted 9 from this equation and found out that 25 minus 9 is 16. That is equal to X squared plus 2AX. We subtracted X squared from this equation and found out that 16 minus X squared equals to 2AX. We divided this equation, equation number 2 by 2x, and finally we found out that A equals to 16 minus X squared over 2x. Then we have already found out that quadrilateral BMDN has 4 right angles. Therefore, quadrilateral BMDN is a rectangle. Why? Because it has 4 right angles, and we know that the opposite sides of a rectangle are equal to each other. That is to say, BM equals to DN. BM equals to DN, but here BM equals to A according to our definition. So for this equation, A equals to BM equals to DN, we derive that DN is also equals to A. Here DN is also equals to A. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we get that BD equals to MN. BD equals to MN, but according to our definition, BD equals to X. So from this equation, X equals to BD equals to MN, we will derive that Mn is also equals to X. Mn equals to X. Then we implemented the Pythagoras theorem on the right big triangle, triangle PDN. On the right big triangle, triangle PDN, PD square equals to PN square plus DN square. PD square equals to PN square plus DN square. PD equals to 6, therefore PD square is 6 squared, that is 36, plus Pn. Pn equals to B plus X, therefore Pn square will be equal to B plus X square, plus Dn square. Dn equals to 8, therefore Dn square is A square. So in conclusion, we found out that 36 equals to B plus X square plus A square. We open the brackets on this side of the equation number 2 and found out that 36 equals to B square plus X square plus 2BX plus A square. Here we have A square plus B square. We substituted A square plus B square by 9. According to equation number 1, A square plus B square equals to 9. So here we get that 36 equals to 9 plus X square plus 2BX. We subtracted 9 from this equation, equation number 3, and found out that 36 minus 9 is 27. That is equal to X square plus 2BX. Here we subtracted S square from this equation, equation number 3, and found out that 27 minus X square equals to 2BX. Here we divided this equation, equation number 3, by 2x, and found out finally that b equals to 27 minus x squared over 2x. So we have the values of a and b in terms of x. And according to equation number 1, a squared plus b squared equals to 9. Found out that a equals to 16 minus x squared over x. So if we square it, we get a square. We found out that b equals to 27 minus x squared over 2x. If we square it, we get b squared. So a squared plus b squared equals to 9. Here we open the brackets of those two expressions. 16 minus x squared is 16 squared, that is 256. Minus x squared is x to the power of 4. Minus 2 times 16 is minus 32, times x squared is minus 32x squared. Plus 27 squared is 7, 27 minus x squared is 27 squared, 2729. Plus x squared is x to the power of 4. Minus 2 times 27 is minus 54 times x squared over 4x squared. 2x squared is 4x squared. And it is equal to 9. Here we multiply this equation number 1 by 9. 9 times 4x squared is 30x squared. And here we have x squared plus x to the power of 4 plus x to the power of 4 is 2 times x to the power of 4, and minus 32x squared minus 54x squared is minus 86x squared, plus 985 equals to 36x squared. Here we subtracted 36x squared from this equation number 1, and found out that according to equation number 1, 2 times x to the power of 4 and minus 86x minus 36x minus 86x squared minus 36x squared is equal to minus 122x squared plus 985 equals to 0. Here we substitute that we defined as x squared as z, therefore x to the power of 4 will be equal to z squared. So this expression in total equals to 2z squared, and we have minus 122 times x squared. We substitute x squared by z plus 985 equals to 0. So we have here a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula, that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, a equals to 2, b equals to minus 122, and c equals to 985. Okay. Also the values of a, b, and c. So we put the data inside the equation for x and found out the value of z, because z equals to x. So here z equals to minus b, b equals to minus 122, therefore minus b is minus 122, that is plus 122, plus minus square root of b squared is square root 1 minus 122 squared, that is 1484, minus 4 times a is 2, so minus 4 times 2 is 8, times c is 985, so minus 8 times 985 is 7880, or divided by 2a. A is 2, so 2a is 2 times 2, that is 4. So here we have z equals to 122 plus minus 14,884 minus 7,880 equals to 7,004, all divided by 4. So z equals to 122, and the square root of 7,004 is 83.6899 over 4. So here we have two solutions that are possible for z. The first solution for z is that z equals to 122 plus 83.6899 over 4. So 122 plus 83.6899 is 205.6899, and if we divide it by 4, we get that z equals to 51.4224. So z equals to x squared according to our definition, and it is equal to 51.4224. So if x squared equals to 51.4224, we take out of this number in order to get the value of x itself. So the square root of this number, it is equal to 7.17 units. So we found out that the value of x is 7.17 units, but it is impossible that the value of x here is 7.17 unit. Why? Because if we focus on the right triangle, triangle APM, the hypotenuse AP equals to 5 units, and the hypotenuse is the biggest side in any right triangle. So AP, the hypotenuse AP, the right triangle, triangle APM, must be greater than AM. So if AP is greater than AM, let alone that AP is greater than AB, that is part of AM. So we found out that AP, that is the hypotenuse of triangle APM, it's equal to 5, and it must be greater than AB, that is equal to x. But according to what we found out that according to the first solution, x equals to 7.17 units. And from this equality, we'll get that 5 is greater than 7.17 units. So it is a contradiction. We got to a contradiction that 5 is greater than 7.17 units. Therefore, we cancel the solution. This is the correct solution. And we left only with the second solution, that z equals to 122 minus 83.6899. And it is equal to 38.3101. And if we divide it by 4, we get that z equals to 9.5775. So here we found out, according to our definition, z equals to x squared. But what is x squared? X squared is the area of that we are looking for. The area of this square ABCD is equal to x squared. And we found out that x squared equals to 9.5775. Therefore, the area of square ABCD equals to 9.5775 square units. We took root of this number in order to find out the value of x, and we found out that x equals to 3.09, and it is indeed smaller than the hypotenuse AP, that is equal to 5 units. So the answer to the question that the area of square ABCD equals to 9.5775 square units. We finished with the first question. Okay, then I presented to you the second question. So in the drawing we have right triangle, triangle ABC. Inside the right triangle we have a circle. Inside the circle we have triangle DOE, and our mission is to find out the size of this angle, angle theta. So we know that AD equals to EC, and DE is twice as long as AD, and DE is also twice as long as EC. Our mission is to find out the size of this angle, angle theta. So first of all, we define line segment DE as 2A. DE equals to 2A according to our definition. And then we have the formula that is given us in the question, that AD equals to the equation that has been given us, the equation that AD equals to EC equals to DE over 2. According to our definition, D equals to 2A, so we substitute DE by 2A. So we have here 2A over 2, so 2 will get cancelled, and left only with A. So in conclusion, found out that AD equals to EC equals to A. So AD equals to A, and EC is also equals to A. Then we have rule number 4, that if we, from the center of the circle, if we draw perpendicular to chord DE, then the perpendicular OT bisect chord DE. That is to say, DT equals to TE equals to DE over 2 equals to TT equals to DE over 2, and TE is also equals to DE over 2. So here, according to rule number 4, dt equals to TE equals to DE over 2, and dt is also equals to DE over 2, but D equals to 2A, so substitute DE by 2A. So we have 2 in the denominator and 2 in the denominator, so 2 will get cancelled. In conclusion, found out that dt equals to TE equals to A. That is to say, dt also equals to A, and TE is also equals to A. Okay, then we join point O and then together by straight line. This is the radius that is bound to the point of tendency, therefore this angle equals to 90 degrees, and this angle equals to 90 degrees also. We have the radius ON that is bound to the point of tendency, therefore this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay. We know that all the angles inside here we have angle ABC equals to 90 degrees because it is a right triangle. So this we have in quadrangle MOPN, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. Therefore, quadrangle MOBN is a rectangle. And the opposite sides of the rectangle are equal to each other. That is to say, MO equals to BN. But MO equals to R, therefore BN will also equal to R. Likewise, according to the symbol that the opposite sides of the rectangle are equal to each other, we get that ON equals to MB, but ON equals to R, therefore MB will be also equal to R. So we found out that MOBN is not a rectangle but a square. Okay, then we presented to you rule number 10. According to rule number 10, if we have the circle and we have the external point P, we have from point P tangent PA to the circle, and the straight line from point P that intersects with the circle at point V and at point C, then the following equation is true, that AP square equals to PB square plus PC square. Again, AP square equals to PB times PC. Again, AP equals to PB times PC. Implemented rule number 10 in our drawing. In our drawing, we have the external point C, we have from the external point C tangent CN, and the straight line that intersects with the circle at point E and at point D. Therefore, according to rule number 10, we get that CN equals to CE over CD. Again, CN square equals to CE times CD. Repeat again. According to rule number 10, Cn square equals to Ce times Cd. So Cn square equals to Ce is A and Cd is 3A. So Cn square equals to A times 3A, that is 3A square. We took out of this equation and found out that Cn equals to square root of 3 times A. Cn equals to the square root of 3 times A. Then we implemented rule number 10, the external point A. we have tangent AM, and the straight line that intersects with the circle at point D and at point E. Therefore, according to rule number 10, AM square will be equal to AD times AE. Again, AM square equals to AD times AE. Okay, again, according to rule number 10, AM square equals to AD times AE. So AM square equals to AD, that is A, times AE, that is 3A. So in conclusion, we found out that AM square equals to 3A square. Therefore, we took out of this equation and found out that AM equals to the square root of 3 times A. Here, AM is also equals to the square root of 3 times A. Then I copied the right triangle ABC in this new page, and here AB equals to square root of 3 times A plus R, and BC also equals to square root of 3 plus A plus R times A plus R. So those two sides are equal to each other, and we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles must be equal to each other. So if one angle is theta, then the other angle must be also equal to theta. So this angle equals to 90 degrees, so the sum of the two other angles must be also equal to 90 degrees. That is to say, theta plus theta must be equal to 90 degrees. Theta plus theta is 2 theta, that is equal to 90 degrees. We divided this equation by 2 and found out that theta equals to 45 degrees. Then here cosine 45 degrees equals to BC over AC. BC equals to square root of 3 times A plus R, and AC equals to 4A. We multiply this equation by 4. And we know that cosine 45 degrees equals to 1 over square root of 2. We multiply this equation by 4A, and we found out that 4A over square root of 2 equals to square root of 3 times A plus R. We substitute 4 by 2 times 2, and then we substitute 2 by square root of 2 times square root of 2. We have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 will get cancelled, and finally we found out that 2 times square root of 2 times A equals to square root of 3 times A plus R. We subtracted square root of 3 times A from this equation, and we found out that R equals to 2 times square root of 2 times A minus square root of 3A. We took A as a common factor from those two expressions and found out that the radius of the circle equals to A times 2 times square root of 2 minus square root of 3. Then I copied the green right triangle DTO in a new page. Here point O is the center of the circle, point D is the point of the circle itself, therefore OD is the radius of the circle that is equal to R. So OD equals to R. DT equals to A, and this is angle theta, the angle that we are looking for. So here it is very easy to see that in the right triangle DTO, cosine theta equals to dt over dO. Cosine theta equals to dt over dO. dt equals to A and dO equals to R. So in conclusion, we found out that cosine theta equals to A over R, but we have already found out that R equals to A times 2 times square root of 2 minus square root of 3, so we substitute R by A times 2 times square root of 2 minus square root of 3. We have A in the numerator and A in the denominator, so A will get cancelled, and finally we found out that cosine theta equals to 1 over 2 times square root of 2 minus square root of 3. In order to get the value of theta itself, we operated the opposite function of cosine, that is cosine minus 1, on the result. In this way we get the value of theta itself. Again, we operated the opposite function of cosine, that is cosine minus 1, on the result, that is 1 over 2 times square root of 2 minus square root of 3, and we got the value of theta itself. The value of this expression, the opposite, when we operate the opposite function of cosine, that is cosine minus 1, on 1 over 2 times square root of 2 minus square root of 3, we get that this expression equals to 24.203 degrees. In conclusion, we found out that the size of angle theta equals to 24.203 degrees. I repeat again, we actually found out that the size of this angle theta equals to 24.203 degrees. Okay? Thank you very much.